Good evening. Hi, good evening, everyone. Thank you for joining us today. I am Miriam Ahmed. I'm Assistant Professor of Graphic Design in the Art and Design program here at NSU. With me is Associate Professor Candy Lopez Moreno, who is also the Program Director of Art and Design. Once again, welcome and thank you for attending today's lecture with Carol Prusa. This is the second lecture in the Art plus Tech Bridging the Gap series, which focuses on how evolving technology influences and integrates with the art market. Last November, our first guest speaker was Oksana Nedavnaya, who is a costume concept artist and illustrator. And coming up on March 8th, we will have our third and final lecture for the academic year by Ivana Tao, who is a Nifty or NFT artist. So we hope you all will join us there too. This lecture series it complements our art and design program exhibition series, and we would like to invite you all to check out our Senior Showcase exhibition, which opens on February 23rd. Following that is our 13th annual juried student exhibition, which goes from March 16th until April 15th. And both of these exhibitions are in Gallery 217 in the Don Taft University Center on the second floor here on campus. And then rounding out the year will be our second annual Student Graphic Design exhibition, which is a virtual exhibition that opens on April 29th, and that will run into the summer. So you can find out more information about these events and exhibitions at nova.edu/arts or by following us on social media at NSU Art Design. So now to the main event for this evening. I would like to welcome Professor Lopez Moreno to introduce our speaker.
Hi guys, thank you all for coming on a beautiful Tuesday night for an hour to hear Carol Prusa speak. I want to introduce her and just talk a little bit about her work. Prusa's body of work involves fantastical visions of cosmic powers beyond us, experimenting with resin, fiberglass, LED lights, and silverpoint. Prusa asks us what lies beyond the unknown. Her impressive geometry and craftsmanship adds to the transcendent aura of each piece, becoming universes of their own. Prusa was born in Chicago and lives and works, or used to work, in South Florida. She recently moved to North Carolina. And she exhibits internationally, including the Bernice Steinbaum Gallery in Miami and Blue Rider in Taipei. Her work is included in excellent public and private collections, including the PAM, or the Perez Art Museum in Miami. For those that live here, you should definitely go to the PAM, really beautiful museum. Also the Museum of Arts and Design in New York City, Telfair Art Museum in Savannah, and the Francie Bishop Good and David Forward collection, which is actually here, and they're part of the Girls Club collection in Fort Lauderdale. I personally know Carol Prusa because she was my professor during my master's program at FAU. And I'm really, really excited to have her come here and speak and share with you guys her process and how she integrates technology within her work. So Carol, whenever you're ready.
Great. Thank you, Candy, for the really lovely introduction. And thank you to Nova Southeastern for this invitation as well. I was privileged to work with Professor Lopez a number of years ago and have seen her work develop over these years. And she recently gave a talk for the Art Salon. So if you haven't listened to her give a talk, it's excellent. I would advise you check it out. So I'm going to share the screen and I'm going to have to whip right through things. And my talk is really going to focus on art and science, and then art, science, and technology. And it's going to be odd for many of you who know me as a pre-industrial craft artist, but I do use technology, and it weaves its way in and out of my work in a periodic kind of way. So the most beautiful experience we can have is the mysterious. It is the source of all true art and science, and Einstein was the person who said that. And if you look at this illustration here, you see that artists and scientists came together to envision our worlds. And this is actually multiple universes. So even back then, they had this concept of many worlds, which interests me. Because I always like to say, if there's multiple universes, in some universe, I just won the Guggenheim. So that's a useful way of looking at life. Like maybe in another universe, we solved this issue with COVID. So whenever you're feeling really kind of down, just think about multiple universes and jump into another one and change your mind about how you feel. So science describes accurately from outside. Poetry describes accurately from inside. And this is a quote from Ursula Le Guin, who's a really well-known science fiction writer. She says, science explicates, poetry implicates. Both celebrate what they describe. We need the languages of both science and art to save us from merely stockpiling endless information that fails to inform our ignorance or our irresponsibility. And we live in an age of speed and deliverability of information. So we're all inundated by lots of information, and artists and scientists really seek to make sense of it. And so now we hear another artist rendering of the world system. And so artists try to put out fully their vision of the world, the same as a scientist tries to describe the world that we live in a way that makes sense and is repeatable. So by replacing unfounded, willful opinion, science can increase moral sensitivity. By demonstrating and performing aesthetic order or beauty, poetry or art can move minds to the sense of fellowship that prevents careless usage and exploitation of our fellow beings, waste and cruelty. And I think this is particularly relevant today to think about, that we do need to turn to science and art to give us really a moral compass and how to navigate the information around us so that we can treat everybody fairly and equitably, and the world that we live in. So an image is a stop that the mind makes between uncertainties. And here we have an image, a three-dimensional model of the plurality of worlds. So this idea of many worlds, and also this idea that the world can be described in a way that's sensible, logical, and follows certain scientific observations. Now, Ansel Kiefer made this image called Every Man Stands Beneath His Own Dome of Heaven. And he's really alluding to the fact that we make a world from our own perspective. So everybody has their own world, much of it overlaps with other people's worlds, but artists are articulate expressors of alternate worlds. And so we offer possibilities, innovation, we critique, we question, we challenge, and scientists try to develop worlds that can benefit us living in them and our understanding of why things are the way they are. So what led me to be an artist really was this question of why is there something instead of nothing? And I don't know how many people thought about this, but this was my 6th grade mind, because in 6th grade, I learned about the Big Bang, which is the explosion of our universe from nothing, the singularity of nothing. And if there was nothing, this is how my mind thought about it. If there's nothing, then what was there before there was nothing? What would nothing feel like? So my little 6th grade mind said, I'll do this project of erasure. And I should have known then that I was an artist, but I thought I was a scientist. So I thought, okay, just methodically just erase the things around me. So, it was very easy to say to erase my house and my parents. And it was easy to erase the neighborhood. But, once I erased the world, the earth, it was like, well, okay, erase the sun, the moon, this, all this stuff. And it's like, but wait a minute, And so at that point I got a headache, and I was like, I'm going to have to study science for the rest of my life so I can figure out how something could come from nothing. And so I really should have become a physicist. And I do adore physicists because physicists think in really metaphoric ways, and they have language that's also very poetic. I also like mathematicians because mathematicians talk about elegance and symmetry. And they like to bring their equations down to a beauty of relationships that are simple and elegant. So there's a language that's shared between mathematicians, scientists, and artists. So in 6th grade, I was certainly born into a family that had a narrow set of like why things were the way they were. And my mind explodes because of science, and logically should have turned to art to free my mind, but I turned to science to free my mind. I thought science would give me the answers, but it was a way of looking outside of myself. And later I turned to art for the same reasons. Artists and scientists ask questions that determine our place in our world and to look at the unknown. They build metaphors and concepts to offer understandings of our world using abstract thinking to express ideas. Both are critical thinkers, seeking new ways of thinking and offering new ways of knowing. Both represent the visible and the invisible. So I think I'm like the Flammarion man, who in this woodcut image is poking his head out of the known universe. So you have this liminal surface of the known or visible universe. And people have always been trying to look beyond, look into the void, look into that thing that we don't yet know. And here he is poking his head out to see what's beyond what can be seen. So my work is really heavily involved in making, and making determines its own set of demands, as well as requiring its own set of materials and methods and technologies. So most of my work deals with plexiglass in the forming of plexiglass. So here the technology would be actually vacuum forming. But at any given moment, my studio will be in a state of flux. This is my studio quite a long time ago. But even having to cut a circle out of a piece of wood has its like logistics, right? It's constantly problem solving. And that's the kind of exciting thing about being an artist, is that you're having to put your mind to solving things all the time. And in fact, once I know how to do something, I'm not particularly interested in it. So every day I like to wake up and learn something new. And I think I share that with scientists, because even if they come up with a theory, they're going to deepen that, and they're going to have to prove it. And then they're going to run into trouble and make mistakes, and they're going to have to reform their ideas. And artists are similar, the same way. So talking about technology, because Professor Lopez requested I do that. Drawing is a technology. And so I work with silverpoint, and I pretty much carry that through to today. I began working in silverpoint when I had the opportunity to travel to Italy and teach for FAU in, I think it was like 2003, maybe it was already. So quite a long time ago. And silverpoint is simply a piece of silver put into a lead holder. And I use that silver to mark on my domes. And where did the domes come from? Well, if I have a circle is a highly symbolic form. So I like the history of symbolic meaning in art. And if you take a circle and you had a point source of gravity, which would become like Newtonian physics, that would give you the sphere, and half of a sphere was easier to work on than a sphere. So that's why I was working on domes. And I was thinking about domes as dome of your head, like the cranium, and the bubble that you live in, so your own dome. So silverpoint drawing, I wash with the graphite wash. The graphite wash is to open up the cosmological field for play, meaning it's going to open up new possibilities for things to emerge from it. And then I heighten with white paint. So basically pre-industrial craft methods, although I'm using acrylic paint, which is a technological development. So all these things that artists kind of take for granted now, that you could buy acrylic paint, all those things had to be developed and manufactured. So here I'm drilling into my dome because I'm making these 1/32 of an inch holes with a tiny drill so I can glue fiber optics to them. So my dome started to have these lights, and the lights would flicker. And partly, I was enamored with the night sky, but I was also thinking about how do I give another layer of information to my work? And I would do that with fiber optics. And those lights would be a different level of information or a different level of mapping on the liminal surface of what I know. So here you see all the fiber optic lines being glued to each individual little hole. And then all those fiber optics are bundled together and run into a programmed light emitter. And the light emitter has a programmed array of LED lights. So as an artist, I just sit at Google almost all day, just asking questions like, oh, how do I do this? I have to say YouTube is particularly useful. It's kind of amazing what you can figure out and learn now. When I was doing this early work, it was a little bit harder to find the information on it. Now it's pretty matter of fact, and people use this a lot for making models, like architectural models. They'll use LED lights and fiber optics. And so you can see these tiny little lights on the surface, and that's from the light emitter running through the fiber optic. And so then, I would have shows, and I'll just point out that here you have domes. These domes all light up. It's hard to see the lights because they're tiny, and there's no cord. So, artists have to solve, like, how do you get electricity to a piece if you don't want a cord to show, So they're great devisers of solutions of things. And I've learned to drop electricity down walls and pull them out other sides. So always problem solving. So once I was able to get the lights on the surface, and here you see the little LED lights, I was thinking, what else can I do to expand the experience of a dome or make the matrix inside feel more expansive than the exterior? And I thought maybe I could do that with video, because video, being a form of moving light, would have like a time and space that existed quite differently than the actual dome, the physical dome itself. So I started making these videos, and I would put them inside the work. And this video happens to be of vibrating strings from string theory. So I took the equations of physicists for describing string theory, and they were made into graphs. And those equations, as they iterated, made all these different shapes that was turned into an animation. So at the time, I didn't think about it as like really using technology, because I think we're all sort of fluid in digital means and using our phones to do a lot of stuff, and making animations. I mean, I was teaching children a couple of weeks ago, and they all make videos and they make animations, and they were like fifth graders. So things that were initially really hard for me to sort out and figure out now are really quite simple. So so most of the time I spend my life in pre-industrial craft methods of drawing and painting, generally on a curved surface. And here I wanted to have light come through. So I had first paint black paint to block the light, and then paint the white paint, and then draw on top of it, and the graphite gouache. There's something really beautiful about taking the time to do something like this, because it is quite the task, but it's a lovely place to put one's mind, because we are in a world where everything is like zooming by so fast. And I think that's why I really can't make myself sit at the computer and be a digital artist, because the speed of all of that seems overwhelming to me. So, but the slow mark, hatch, makes more sense to me as a human being. And so that's primarily how I work, but my mind is always like thinking of other things, and I want to learn new things, and I also want to check out new things. But what I'll point out in this image is that dome that I was working on, and now you can see how it's first painted black, and then I painted white and drawn it, but that dome has to be mounted. And so how do you mount something like that? So then you have to run tests with glue. So you buy like 5 different kinds of glues, and then you glue plexiglass blocks to each other, and then you make like a seesaw. You're going to put weights and see at what point is it going to break. So what will hold the strength of the piece to the wall. Fortunately, my partner is a mathematician engineer, and he can do the moment calculations to make sure that this really works well. And he loves experiments. So the fun thing in a studio is to run these experiments, run these tests. It's you learn so much. And so I like projects and problems where I'm like, I don't know if I can solve it, but in an iterative way, trial and error, and also mathematics, and then talking to experts to get advice, and then testing out different glues, you can come up with a solution where when the piece got hung on the ceiling, it doesn't fall down on somebody, because that would not be good. And so artists, I believe now that artists really need to learn to ask for help, to go on YouTube and look at how things are made, and then seek out experts, because we can't possibly know everything that's possible to do, but somebody will, and you can get them to help you. And remarkably, people seem to like to help artists. It's really lovely. So my mind likes to learn new things, and so I got accepted to go to the Kohler factory for an artist in industry residency. Now, I'd never worked in ceramics, and so here's where I had to use their factory methods to make work. In fact, I never worked in clay, so the first thing that I had to do was to take a lump of clay and make a form, and then learn how to make a mold. Fortunately, I'm a quick learner, so within a couple of weeks' time, I had made all these forms, and you can see my plaster molds on the rolling tables, because I'm going to slip cast them and make multiples. And so you can see the forms that I'm making are maybe, I don't know, maybe 2 feet at most across, not really big or anything. And those molds are pretty heavy. So that was sort of my level. And so I made them, but once I made the slip cast mold, you have to make sure that the clay drops out. This is where the engineering mind comes in, because clay, when it's slip cast, will slightly shrink when it starts to dry, and it's going to release itself from the plaster, and you want it to drop out like a jello mold, right? And if you don't have your angles just exact, it will grab, it'll break, it's not going to work. And I wanted to work with 1 part mold because it was just going to make it a lot easier, because I wouldn't have to clean up the seam. So it's like, oh, and I had never worked dimensionally before. So it was all very fascinating, and learning to do this. And you can see now that these pieces are gray, and that is because Kohler factory, if you know their sinks and their toilets, most people's kitchen sinks, bathroom sinks are white, certainly not black. I'm sure there's black sinks, but I haven't seen one. But they're mostly white, and they're mostly shiny. And I didn't want shiny, and I didn't want white. So that's where I had to go meet with the chemist in Kohler factory and discuss, well, how do we mix up a glaze that's going to be a matte black, which is what I wanted. And so here I am, I'm sending my pieces through the tunnel kiln along with the urinals and sinks and pedestals. And my pieces are gray, and they're going to come out black. So again, I didn't possibly have the lifetime it would take to really learn all the clay glaze chemistry. But by being able to ask good questions and being curious about possibilities, as an artist, I can extend my reach through other people's abilities and technologies. And so here I am in the studio working and making these things. And of course, I was getting good at it. So I could make these things. And I'm like, okay, now what can I do? I was there for almost 4 months. So there's quite a bit of time. So then I thought, I'm going to make the biggest thing I possibly can make. So here I'm making the clay model. And here I have to be good too, like not just of engineering, but also geometry. But here with the engineering, again, I'm going to make a 1-piece mold, and all of this has to drop off. So as an artist, I have to think about all these 90-degree angles. So I have no undercuts. And yet I don't want it to feel forced and confined in that way. So kind of really pushing the margins of that. And here I'm making the piece. Here's the final model. Once I had the model, I have to make the mold. Now, the reasons they're all excited is I built the form around the mold, and so that the plaster could be contained. And they're like, it's going to blow, because it's going to be a lot of plaster. It's going to be a lot of weight. And this is where artist engineering mind better be good, because I'm like, no. I stayed up all night to do this. It's going to work. It's going to hold. I have enough C-clamps on there. And sure enough, I lucked out. It held, so they didn't get quite the fun they wanted. And this is the mold, and it's enormously heavy. So I had to use a chain lift to move it. So now I'm slip casting this enormous mold. And I felt like pretty confident, like, look what I did. You know, I made this really big thing, and this is exciting, and wow. Problem. When it started to dry, before it could go into the kiln, it would pull in on itself and it'd shrink, and that shrinkage grabbed the plaster it was on, and the bottom just kept on cracking and cracking. And so the engineers from upstairs at the Kohler factory all came down, and everybody consulted, and nobody could come up with a solution. It was kind of mildly heartbreaking. So there was one piece that did make it where it didn't crack, and there it is going in the kiln. But when it got shipped back to me, it was broken. So, but the positive is, an artist, you're a problem solver. You're always a creative problem solver. So I took the mold and I filled it with silicone to make a silicone positive, brought it home. That's my, it was the drawing studio at Florida Atlantic University. And this is when you need family who have your back. And so my partner and my son, they're helping me chip off the plaster to expose this silicone mold. And once I got the silicone mold exposed, I could move along and convert it into a rubber negative to make fiberglass positives. So anyways, the image on the left of me is just showing that you better be tough as an artist. You've got to grit it out, you know, so that's me being really, really tough. And there's my studio as it evolved after the Kohler experience. And the thing that I'll say about going to the Kohler factory to work is that what I learned by stretching myself in that way was that I was far more capable as an artist than I really appreciated or realized. And just having a glimpse at my possibilities when I worked with other people and asked experts to assist me with things was transformative in my life. So these are some pieces that are done in vitreous China, slip casted Kohler factory with fiber optic lights in them, and then silver point drawings in the middle. So I've made a whole bunch of those. They're now all in boxes in my basement. So they're my big storage issue. But I converted the huge ceramic piece that wouldn't fire without cracking. I converted that into the fiberglass. And the great thing about that was I didn't have to make the fiberglass. I could hire somebody to cast the fiberglass for me. So these black pieces are fiberglass, and they're sprayed with black, matte black automotive paint. And then I put the fiber optics in, and then I do the silver point drawing in the middle. And then I do have all the fiber optic lines running to each of those little peaks, and it kind of lights up and flickers going to a programmed light emitter. And there's a close-up of the silver point drawing, and you can see there better all the little tiny fiber optics. So making art is not for the faint of heart, but people always say, oh, you know, don't you get tired or don't you get bored? And I'm like, no, never. Two things that entertain me when I'm making my work, NPR for one thing. I listen all the time to it, but the other thing is my mind is pretty active. It has a lot of going on, very imaginative mind. And so I'm always thinking of the next thing. So I'm working on those fiberglass pieces. And I'm thinking, what next? What could I get next? I don't have to make it. Okay, so here's a computer model in the upper left. And this is like so cool because you can get like pretty cheap free shareware versions of CAD models. You can get some pretty nice stuff online where you don't have to spend a lot of money and model a form. And then I sent the file actually to California, and it was printed in sintered nylon. So it's 3D printed, and you can see in the upper right the three pieces to make the light, and the lower left once I've glued all the pieces together. And then there's a close-up. You can see the 3D printed nylon. And then when it was lit up. And so I thought, this is me, because I think it was brought up in the beginning of maybe connecting to market or commerce. I thought this would be really great because I can make these lights and I can like somehow make money. But the 3D printing, I don't know, you know, if you wanted to guess, put a number in your head of what you think this costs to make. And I'm sure it's more than that because this cost me $2,000 to print that thing. I know, right? Now, I'm sure the prices have come down, but, you know, I cannot compete with IKEA. But I thought the next thing I'm going to do is I'll work with CNC routing, because the great thing is at Florida Atlantic University, the architecture department had a CNC router at the time, and now sculpture does as well, because I think this equipment has gotten really rather commonplace. And this is where the computer is driven by your drawing to cut out the plexiglass. And so here I have my model on the upper left, and then the outcome is on the right. And so here I am making the piece, blocking the light with black paint. And then here's the final piece when it's lit up. So it has all these fins of plexiglass. Now, the next thing I did was wanted to make an enormous one. And I have all the fins cut out, but I never had a studio with big enough doors that I could build a thing and then get it out the doors. So now I do. So that was a reason to move to North Carolina, is I could sell my Boca house and get a really big studio in North Carolina, where now I have big enough doors to make a really big one. So I'm kind of excited about that. So then my mind goes to, oh, well, not so much my mind went to, but I was invited by the Boca Art Museum to go to Venice to work in glass. They were going to have a big glass show. And this was really cool. So I had to research a lot. I had to look up, like, well, what kind of glass could that furnace make? And how is glass made? And how could I work in glass in a way that looked like my work? So a lot of research. And then I did a series of drawings. So what I decided was I was going to make this toroidal shape and working with Venetian glass. And this was my drawing. And when I got to Murano, I showed it to the maestro. He's the guy sitting down blowing the glass on the left. Now, the only method I had available to me was glass blowing. So everything that I had to think of to be made was going to be through blowing glass. And so, and also I didn't speak Italian. He didn't speak English. So it's a good thing I knew how to draw. And so that's how we conversed. So always being a creative problem solver. And the exciting thing is that when you work with somebody who has trained since they were young, it was in his family, that this was passed down family to family, that what he is interested in working with me is the fact I'm going to ask him to do something he's never done before. What I'm interested in doing and working with him is he has the technology and the skill and the ability to expand my vision in materials that I couldn't possibly do unless I spent an entire lifetime pursuing it. So here he is making the glass, and you can see now those little like flower shapes that are coming out. I think of those as portals, like they're additional portals going to the wormhole. And then if you look at the detail up close, you see kind of that gray stuff, and that's actually iron. And I was thinking of that as it gave it this kind of cloudy, filmy structure that made me think of the walls, voids, filaments, and clusters, which are the building blocks of the universe. And so here's one of the resulting pieces made in glass. So that was like really fun, but now I'm back wherever. I don't have a glass furnace. I don't have a maestro to make the glass for me, but there's something about when you experience these things, they do put your mind in different arenas so that they precipitate other ideas, certainly. So here I'm back on a 36-inch sphere with my silverpoint drawing heightened with white, and then I have a program light inside. And that program light causes the piece to slowly light up and slowly fade down. And the reason I actually wanted the light to come up really slowly was when I was a kid, I would just go to downtown Chicago while my dad was taking a class downtown, and the kids, all us kids and my mom would sit by this fountain in downtown Chicago that would light up, and then the water would come out, and you have to be patient because it would be doing nothing, and then all of a sudden it would start, and this idea that if you turned away, you would miss it, or you might think it was one thing, but then it was this other thing. So I like that, this kind of really slow revealing of the piece as it slowly lights up and slowly fades. And it sort of drives people crazy because it's so slow in a way that people don't have patience. It's like, wow, they can't even wait for a 30-second, well, it's a minute and a half cycle. Like, wow, okay. This piece again, 36-inch sphere called Aurora. And there you can see some pieces in installation. This happens to be at a show in Blue Rider Gallery in Taipei, Taiwan. So, as I'm like gathering information about doing things in lots of different ways, it just struck me, maybe it was my age, that I started to think about night. And I think my earlier work looked like dawn or maybe dusk or dawn, but now I'm thinking night. But I had an experience in Italy that actually precipitated this thing at night where it's too long a story to go into, but it started me working with blacks and experimenting with blacks. And here's my studio. But I just want to show you a little bit about how I proceed with my work now. And I just do these kind of extravagant pours, and then I build them up with white paint and other ground up pigments. And I'm trying to get this idea, like my favorite thing to do when I was in Florida was to ride my bike home from the graduate studios at night on the bike path without my lights on, so it's like dark. And when you look into darkness, your mind is going to fill in what it thinks it sees. And you get this kind of flickering, it's called scotopic vision. And you're trying to resolve something from nothing, and that really intrigues me. So it's kind of emerging out, like bringing form out of something that is nothing. So I love this quote by Agnes Martin, that the work is about perfection, the perfection I can form in my mind. However, the work is far from perfect and must incorporate the accident and complexity of flux and flow. And so my work always has an embedded element of fluid. So I do washes and I do pours to allow the materials to settle out in the way that they want. And this sort of arose when I worked with a Russian iconographer at a Buddhist university, where this idea of like denying ego and just letting the materials do what they will do. And then asserting ego on top, I suppose, in the end. So here's the final piece, which set me down thinking about night sky, because I realized I was very attracted to night sky. And so I started to research astronomers and read books about the universe. And the one that I'll point out here, Maria Mitchell, I read her journal, and you'll see where that evolved. But I just love reading, and I like reading about science. And then there's this wonderful book, A Sense of the Mysterious by Ellen Lightman. Those are all wonderful books, but the one book I will strongly recommend tonight that people read if you want to know why the universe is the way it is Mapping the Heavens. It's a really great book. It's really readable without being too simplistic. It's a wonderful, wonderful book. So, but I read the journals of Maria Mitchell, and she was a very early American astronomer, and she was famous because she had discovered a comet and got a medal from the King of Denmark. She also determined the trajectory of Venus from the perspective of Earth, which is quite a calculation. And so she wrote about going to see an eclipse and how transformative it was. And I thought, I've never experienced a total eclipse. And there happened to be one that was going to occur in 2017. So I decided to go, but I decided at the last minute. So I ended up, I couldn't fly anywhere everybody wanted to be. So I had to fly someplace nobody wanted to be. So I flew to Nebraska. And so, and I was able to rent a car. So anyways, because I had to come back and teach. So I had to be teaching like at 24 hours after this event. So the whole thing was a little nuts, but I saw the eclipse, and here it is in full daylight. And then during the totality of the eclipse, that's how dark it got. And she Maria Mitchell wrote about her experience about this and how it impacted her. And I read the writings of a number of other people, like Virginia Woolf wrote about it. But it was so unsettling when Venus popped out during midday that I did lose my grounding and I did fall backwards, which sounds kind of like ridiculous, but it did happen. So I had taken a video of it in case I could use it for art or something. But then I went back and started researching images of eclipses and thinking about what did I see and trying to come to terms with the strange light. It was really the light that was so peculiar because it was so silver toned. It turned to palladium. The color of the light was very interesting to me. And so do all that research, and then my studio formed kind of like gray tones to these kind of darker tones, and different kinds of forms started to come in. And so I did this series where I was really depicting what the eclipse looked like to me. And here we have the crescent. If you look up in the upper left, it's the crescent where it's not in totality. So, just a little bit of light peeking out. And I did some quick sketches for memory When Mariah Mitchell went and observed this in Denver, she took a group of women astronomers with her from Vassar, and each one was assigned a task, like a timer and a sketcher and a, I realized it's really hard to grab all the information really fast, even if you're fast drawer, because you don't want to stop looking. So, I was trying to draw and look at the same time. So here's what they call a diamond ring, where there's just a little bit of light poking out. Totality. And then the whole series together. So the largest one is 60 inches across. So once I had depicted that, then I was like, okay, that's what I think it looked like. That's what I think the light looked like. And if you remember, there's a ring around each work and of these kind of forms. And those forms are, I should go back and just show you, those rings are portals into the thing I don't understand. So the exterior is the illuminated surface of the world I exist in, but those forms themselves are biopoetic forms built on embryos at the indifferent stage before they're male or female. Because people often ask me about where those forms come from. So then it's like looking past my biology, my location into the unknown to try to come to terms with it. Once I had come to terms with what it maybe looked like visually, and I thought I had grasped a little bit of the feeling of the light, then I was like, well, what did it feel like? And then try to use materials and forms in a way that expressed what it felt like. And these are 36-inch square panels. So I work highly abstractly and symbolically. And you can see the silverpoint hatching still in these forms. And I know I need to really speed it up. So I'm just going to zip. So my studio keeps on transforming. And then I made this piece that actually is about the birthing of stars. And you can see the star field in the middle. And then you see the accretion disk around of stardust around the perimeter that's going to form everything. This is a really important piece to me, this piece called Cosmic Web. And what it does is it honors a number of women astronomers. And they were called the Harvard computers. And they were called the computers because they sat and did the hard work of doing all the calculations that led us to the understanding we have our universe today. And in particular, Henrietta Swan Leavitt, she did Leavitt's Law. And if you don't know Leavitt's Law, you want to look it up. I'm not going to go into it, but let me just tell you that each lobe is honoring one woman and the information she gathered about our universe and putting it out there in a web to connect with other information that has transformed how we view our world. And one of my favorite scientists is Vera Rubin. If you don't know her, look her up. So there is the piece. It's a 60-inch dome. And there's a close-up of one lobe, and it's for Margaret Harwood. And so I ended up having to research each scientist and read the research and decide which ones. I mean, there's hundreds I could have chosen, but who was I going to choose to name? Then I did this piece called Quintessence. Quintessence is the fifth element. And in the middle, I actually depict the eclipse. And the fifth element is the ether, the mystery. And so I was talking about how the whole event of the eclipse to me was mysterious, and I gave it that same fivefold geometry. And you can see that the light in the video goes really dark. And then the sun came out. It's a very long video, a couple minutes, so I'm not going to show you. Then swerve, like now what? I decided I wanted to honor the women and their research a little more specifically. So I would work in printmaking, and I happen to know a wonderful printmaker, Kim Spivey of Ground Printmaking, and she uses non-toxic printmaking practices. So here, her technology of printmaking opened up my world. So when you don't know how to do something, or you don't have the technology like a press, then you have to work with other people. And working with other people can really expand your vision. And so learning how to do a hard ground and making the etching plates, soap ground, inking up a plate, all these things were new to me, but I had ambition. So I came up with a project, and these are proofs. And each print ended up being 3 plates per print. So then I decided that the capstone kind of print was going to be Urania, the goddess of astronomy. And the whole series is called Galaxias Kyklos or Milky Way. And so here, once I had the proof of that plate, I took it, I scanned it, and then I used it to laser etch plexiglass and build plexiglass boxes. So once I had the laser etched plexiglass, fill it with paint to make it show up, and then build these plexiglass boxes that house the prints. And then I had a letterpress colophone made down at IS Projects in Fort Lauderdale. And I didn't know anything about letterpress, but I was so thankful that I worked with them because later on they invited me to do a book, and you'll see that in a moment. But it's like these things, always like learning. It's so exciting. That's the greatest thing about being an artist is you just get to learn. And so here's the final print of Urania. And she's standing on all these texts that were pivotal to our understanding of the universe. And then there's the Copernicus's universe and the Ptolemaic universe. And then there's the women who I honor in the prints. And I won't tell you about each one of them, but each one of them, like these prints, 3 plates per etching, but the center image is really based on the research of those women. So it doesn't depict the research, but it honors the research through the image. So those are those prints. Then I was invited to go to Taipei, Taiwan to do a piece where, well, what I did was I decided I would do a piece where we're going to project a big video because it was cheaper to send a video to Taiwan. So anyways, they had to make a video. So I had to learn how to video edit. Now, when I made this video, it was not so great, I will be honest, and it frustrated me. So then I wrote a grant to learn how to do video editing really well. And I worked with somebody, Jared Kornbluth. Anyways, he helped me learn how to video edit and sound edit much better. So if you go to my website, you could actually see this video of Folded Worlds, so much better. Anyways, they did yoga underneath it. It made me so happy. Then I had to show at the Boca Art Museum with many of the pieces that we've been looking at. And the show was called Dark Light, and it really was to honor the eclipse and the women of astronomy. And in particular, the show ended with a large piece, a 7-foot square panel, which was an elegy for Rebecca Elson, who was a poet and an astrophysicist who was working on dark energy. She was very brilliant. She died at an early age. So here you can see my work being generated for that piece. So these kind of fluid pores to let things do what they're going to do so that I could respond to them in a kind of elemental way. So I'm very interested in this idea of going back to that Big Bang, that Big Bang, the information of the Big Bang never goes away. We are tethered to it. We will never lose our connection to it. So everything that came from that is us. We are all that came from nothing. And because of that means we're all interconnected. This is an important aspect in what I think about. So where the boundary between myself and what I observe is blurred, but also the boundary between myself and you is blurred. So then I started a series of night gardens because I started to look at my garden at night and try to see things when it's really dark out. And I said, well, that's what it looked like. So it came from my imagination. It's a detail. So then I decided to do another print project. I worked with a mathematician. And what I'm going to say about this is he was a quantum computer mathematician. He was looking at encryption through using quantum theory. And in this, I represent a photograph that was proven recently that entangled quantum particles have no objective state until they're observed. And it's a really beautiful image. In which case I actually rendered it really faithfully. And what I say is the pixelated information is rigorously rendered, allowing me to swim in the strange beauty of paradox among waves of probability and possibility while tethered to the Big Bang. So this is important that I like to swim in the mix of all these ideas. That's why I turn to scientists for these brilliant, outlandish ideas and where they get to with them, particularly physicists and astrophysicists, and come to terms with how amazing and beautiful it is that we actually are alive. the probability of that is not very good if you think about it. It's fascinating. And the mathematician Rainer Steinwand was marvelous to work with. You know, we both expanded our worlds by coming together for a common language. And this is our print. And his equations are that kind of silvery color that's put on top. And he's going to solve our issues that we have with security, because he's going to do quantum encryption for security so that people won't take your money from your bank. You know, it's a good thing. So yay, technology. Okay, so then I started this series called Unknowing. And I was thinking, how could I encapsulate all the things I know and think about the universe? And I see my time is out. So I'm going to go really fast. It houses all foundational equations of how we came to be. This is our universe now. We're there, very fertile. And you can see these on my website to look at them better. And very fecund. But then what's going to happen next? And people talk about the big bounce because of the Big Bang. We're going to have the big bounce or the big collapse. But I give the Star Wars a new hope. You know, I'm a very hopeful person. So, and then I got the opportunity to work with book because I was doing printmaking and I did the color foam and eyes project. They asked me to do a book. We're going to whip right through it, which, you know, I had to draw, which is pre-industrial craft, but I had to translate digitally to make the letterpress plates. And then I had to learn marbling, which pre-industrial craft again. So always alternating between different levels of technology, both old school and new school, and then transforming things into a very old form, which is a book, which I love. You know, it's a very tangible old form. So you see the Vauvel on the left, which is a scientific instrument for figuring things out, and a silk covered book. And I'm going to really whip through this. I hope you can go to IS Projects and see a book in person because it makes a big difference. And if you see this book, this is where I disclose what I really think about things. You know, so I made myself quite vulnerable because now this is my writing. So what good does my art do? I argue art doesn't have to do any good, though it often does. And so by not seeking to do good, then you're not following any kind of power structure. You have to be completely free, and art is a completely free space. And what I'm interested in is communicating my awe of the immensity and unruliness of life and the mystery that we are at all possible. And then to acknowledge that humans are not supreme. So painting the age of artificial neural networks. We all know AI is transforming our lives, and we have to come to terms with that as artists. So I'm investigating these neural networks now and what they can offer to artists. And I'm doing that particularly right now by working with Google Deep Dream, which is a real good starting point for anybody who wants to do this, and then extending it with other algorithms. And the conversation I want to have is, if I train a machine on what my work looks like, what can the machine offer back to me? And what is the starting point for that? So right now, I offer the machine images of my work to train it, but then I also give the machine words that I wanted to add into my work so that I could use it maybe as a studio assistant. So I might say, you know, something like, oh, here's the videos that I put inside the pieces I'm making. So here is actually where the machine was trained on that one piece we saw, the night garden. And the words I gave it were black cloud rose. Okay, and so the machine looks at my work and it's going to say, okay, I want my work to look like a black cloud rose. This is what it's going to offer. It's a very strange thing. And so the thing that you learn by working with technology is that, you know, if you're working with algorithms that somebody's developed, you're going to be limited by those algorithms. So in order to be truly creative, you're going to have to work into it or add more into it, because there's going to be constraints. Just like long ago, people say you would be photoshopped, right? You know, something looked photoshopped. You can tell when somebody's done a Google Deep Dream, you know, transformation. It looks like it, and there's a number of the programs. So But I do believe that artists need to be part of this conversation, driving this technology, which is why I've looked into it. I'm going to do a whole project this year about this. Before I go back to my pre-industrial craft methods, I always have to have an excuse for that because that's truly what I love to do. All I want to do is really express a strange beauty that unites us all in our embodied relationship with the cosmos. Thank you.
Thank you, Carol. That was awesome.
Yeah, sorry it took so long.
No, it's okay. I mean, we love the pictures. If you guys have any questions, we have 3 minutes left. And if you don't answer those questions, you can always email me. So I'm going to put my email address in the chat. Or you can always email your professor or Dr. Ahmed if you want to do that as well. So if you have your questions, let's do it. No hands raising.
Actually, I have one. I was wondering, so instead of like using the fiber optic cables, like what's the difference between using like LED, for example? Is it just like the weight that it brings to the product? Like how does that impact the final product?
Oh, well, the LED lights light up the fiber optics, and the reason for using the fiber optics is to just, the fiber optic line brings that light in a truly brilliant way to that endpoint. So if I had just put, say, an LED light inside the piece and had it flicker, for one thing, everything would flicker all the same around all the little holes, and the light drop off, you know, you learned this in 6th grade too, how much light drops off, right? It just wouldn't look good. You could not get the light to travel through that 1/4 inch of plexiglass well enough to really see it very well. So the fiber optics is pretty important to getting that point source right there. And as well as going to the LEDs, that light array, I can send different fibers at different lights that go on at different times. So I can have different patterns of lights going on the outside of the piece.
Okay, no, I understand. Okay, thank you.
There's a question from Tristan. How do you go about finding the people you want to collaborate with?
Oh, great question. Sometimes, fortunately, they were people I taught, right? They were my students. And then they exceed me in many ways. And then I'm like, oh, now they know how to do this and I don't know how to do that. So certainly in printmaking, I reached out to Kim Spivey because she had been my MFA student and saw she was running a print studio, and I thought I've never done that. Also, I wanted to bring attention to her studio, so I thought I could write a grant and somehow the two of us could work together and that would be mutually beneficial. But otherwise, I apply for artist residencies and you meet people there. If it weren't for COVID, I would have done this one that was called Science Delirium Art, which was going to be at Jurassic in San Francisco. And that was going to be really cool because half the people coming were going to be physicists.
Like my Zoom? Look at this. It's not working.
So, you know, working with residencies, and sometimes, you know, people are extraordinarily nice. You go on Google and you come across something and somebody tells you how to do something and you email them. People are so nice. Now, some people are jerks for sure, but you know, most people are really nice. People help me.
Thank you so much, Carol. We've made it 7 o'clock. If you guys have any more questions, again, you can always email me or your professor. Daniel, we get that answer for you. Thank you guys so much. And I hope you enjoyed it. Thank you, Carol.